All right, everybody, welcome back. In today's episode, what we're going to do is drop an item into the world. We're going to drag and drop from the inventory. You're going to drag it. You're going to click and drag and hold from the inventory item list, and you're going to drag off and drop it into the world. And then when you let go of the button, it'll drop your item out of your inventory and spawn it into the world. We're going to have that as a server authoritative item drop, and we're going to have everything replicated. So first thing I want to do is come into the inventory here, and I'm going to add a class, which I'm going to add an actor called item actor. And we'll do that, or you just add a class to your inventory called item actor, and come delete these. I actually don't even need begin play. I just need the constructor for now, so we can delete all this. And then I can set this to false. First thing I do is say set replicates true. We'll leave that there. And then I need a private section, and we will need some variables. So first I'll need an f gameplay tag. F gameplay tag. Include tag container, and this will be item tag. And then I'll need an int32 called num items, and set that equal to 1 by default. And then I will need an f equipment effect package that I'll add an include called effect package. And then we need one t object pointer to a use static mesh component, which is going to be the visual representation of the item in the world. So it'll be their mesh, giving it a U property. We'll do visible anywhere, and meta equals allow private access. Ooh, private access to true. We'll do that. And then I have this. And now I can take the mesh, and I can set that equal to create default sub-object of a use static mesh component called mesh. Take mesh. So I'll set root component to the mesh to start with. Then I'll take mesh, and we'll set collision enabled to e collision enabled, no collision. And I'm doing this for a reason. No collision. And then we will set the mesh. You say set is replicated to true, like this. And then how we're going to actually set these variables is through two public functions. The first one is going to be called set params, and we're going to take a const frpg inventory entry, and we're going to forward declare that by pointer that we'll call entry, and then an int32 called num items. And the second one is void, and then this is going to be set mesh. That'll take a use static mesh pointer that we'll call in mesh. And by the way, I have to call this in num items, because you can't call this num items because I already have this num items. Can't do that. So this will be in num items. And then we want to forward declare this, by the way. You want to forward declare this. That way I'm not including the entire inventory component to use this as a parameter in a function. So you can do that. So we'll set these set params. Then we're just going to say if entry, because I can't say if is valid entry. Is valid is for objects. This is an object. So we'll just say if the pointer has data there, if entry. Then we can take the item tag and set that equal to entry has their item tag. And then the effect package, we can set that equal to the entry has its effect package. And then we'll take num items and set that equal to in num items, and we'll do that. And then set mesh, we can say if is valid mesh. Then we can take mesh and set static mesh to the in mesh. We can do that, and now we have an actor class that's replicated and everything that we're going to set params and everything independently. So we're going to come back to the inventory component. And my thing is, I don't want to spawn this into the world from a component. So we're going to take all this, the fact that it was dropped, and we're going to send all this straight out, and we're going to let the player controller actually spawn it into the world. Okay. So we have add item, use item, and now we're going to need drop item. So we're going to say void drop item, and this will take a const frpg inventory entry that we'll call entry, and an int32 called num items. U function blueprint callable. And we can generate a definition that I'm just going to drag to the bottom. And then we do want this to be a server function, so we're going to say void server drop item with the same parameters, FRPG inventory entry called entry, and an int32 called num items. I'll make this a U function, server reliable. Now, actually, I've never actually really talked about what the difference between reliable and unreliable is, but there's also unreliable right here. You can make unreliable if you want, right? Now, unreliable RPC is essentially the client sends it off to the server sends it off to the client. If it doesn't happen on the other end of the network, then oh well, it doesn't matter. Like the game doesn't care and it doesn't try again. But if you mark it as reliable, then it has a message system where it sends it back and forth, and the server and the client communicate and make sure that the client and the server both have called the function. If it doesn't, it keeps recalling it until it makes sure that it happens. So because of the potential extra network coverage, you don't want to sit there and make everything reliable, every single one reliable. But the thing is all of the ones that we've done so far, adding an item, using an item, now dropping an item, these are very critical functions that you don't want. You want to make sure you don't want to say, oh, drop an item into the world, and then, oh, well, if it doesn't happen on the server from the client, it's an unreliable RPC. Oh, well, it doesn't matter. It didn't happen. You don't want that to happen. You want for sure that item to get dropped in there. So we're making all these reliable because of that we're doing. But that's just, I don't think I've ever gone into the difference between reliable and unreliable, but that's what it is. So we're going to have here, and in drop item, we're going to follow the same thing. We're going to say if not, get owner has authority server drop item passing through the entry and the num items, and then return. And in the server drop item, we're going to call drop item passing through the entry and the num items. And then what are we going to do actually in the drop entry? We want to just kick this out to the player controller. So we're going to declare a multicast delegate 2 params, and it's going to be f item dropped signature, which will broadcast an FRPG inventory entry pointer that we'll call entry, and then it'll broadcast an int32 I'll call num items. Like this, that we could just make an f item drop signature that we'll call item drop delegate, like this. And then now that I'm on the server, because I'm past this line, I can take the item drop delegate and we can broadcast the address of the entry and then the num items. We can go like that. Because now that we're doing that, we'll come back into the player controller, and in the bind callbacks to dependencies right here where we're binding to our delegates, we can take the inventory component that we have here and we can take the item drop delegate and add a lambda to it, right? Recapture this, and it gives us 2 params, a const FRPG inventory entry pointer that we call entry, and it gives us an int32 called num items. And then we can make our lambda, and because we have that, then we'll make a function called void spawn item. And it'll take a const FRPG inventory entry that we forward declare pointer called entry and an int32 called num items. And then what we could do actually is, in order to do this, we're going to need a location and something to spawn. So we need a location. And in order to do this, I want to make a float so we can make this easily editable. And we'll say this is item spawn forward distance. I'll set that equal to like 250 by default. But I'll make this a U property and say edit defaults only, categories, custom values, item spawn. I'll generate a definition for spawn item. And then in here we can just call spawn item passing through the entry and the num items. So now that I have this, now I'm going to spawn an item for real in here. So I'm going to say if entry, right? So if there's data inside that entry and is valid the inventory component still, we're going to get a const f vector that we're going to call forward location, set that equal to, we have get pawn for the player, so we need to get the get actor location, because we want to take where they're at right now and get the pawn, get the get actor forward vector. Let's look straight ahead of them times the item spawn forward distance. And then we're going to make an f transform called spawn transform and take the spawn transform, call set location to the forward location. And now that we have that, I can take an a item. We can actually spawn this, an a item actor pointer called new actor, And we don't have to track these, right? You just spawn into the world. There's nothing there to track right now. We don't need this player controller doesn't care. Then no one's going to care what happens to spawn in the world. So there's no point in tracking anywhere. We just make a local new actor and dispose of it and we're done. So we have this and we're going to say get world so that we can spawn an actor deferred of an A item actor. And because we're not doing anything special, we just need a default object that we're going to be setting these params here manually ourselves. We could just take an A item actor and call the static class and not even take up any memory for it. And then the next thing it needs is the spawn transform. And then it doesn't need any parameters further than that. So now that I have the new actor, however, we can take this and we can say set params because we have the entry pointer and we also have the num items that we can give it to it. And then we need to set the mesh, but the mesh, where do we get the mesh? We're gonna come to the item types. And in the master item definition, we're gonna look at a couple things here. One, this icon is a T object pointer. Bad me, right? This is a table row based. We're doing this in a data table. And if we're doing this inside of a data table, we need to not be using regular object pointers because those are all going to load into memory as soon as it brings up the data table. So if you have 500, 600,000 items, whatever, it's going to load all textures into memory as soon as you do that. So why don't we start by making this a T soft object pointer of a texture for the icon, and then we're going to come right above it and we'll make another T soft object pointer to a U static mesh. And we'll call this item mesh and we'll set that equal to null pointer. Give this U property of edit, defaults only, blueprint, read only. And we're doing more soft object pointers because again, these static meshes, what if you have high quality meshes, right? You got some nice high quality meshes, bunch of tries, and you don't want to load 500,000 meshes into memory. You just leave them as soft object pointers, right? So now that we have the item mesh that we're going to put into the item definition, we need the item definition. So if we take the F master item definition, take the item, we can take the inventory component and say get item definition by tag, and the entry has the item tag. And then this is now a soft pointer. So we need to, if is valid, we're going to ask for the item mesh being valid the first time. Then if it is, then we're going to take the new actor and we're going to say set mesh to the item.item mesh.get. And then take the new actor and call finish spawning with the spawn transform. But if it's not, because it's a soft pointer, then we're going to need the F streamable manager that will capture by reference called manager and set that equal to U asset manager get streamable manager. And we don't need to make a weak object pointer to ourselves because there's nothing that we need. I don't need anything. This is all just local variables, local stuff right here. So we're just going to take the manager and just request an async load of it is what it is. And we'll take the item.item mesh.toSoft object path and then capture. We'll look at what we need to capture in a second. We'll make the lambda and then we just need to copy these right here. Get these into here, and then I need the new actor, I need the item, and I need the spawn transform. And then now that I have this, that should be it, I think. Let's compile and load up and get into the editor. All right, now that we're back in the editor, we're gonna come into the third person, into the blueprints, into inventory widgets, and we're gonna come to the item row. Now in the item row, we're gonna want an icon now. We want this icon and we're gonna put it all the way to the left of here. So what I'm gonna do is duplicate this spacer. I'm gonna put it right here, and then I want a size box. And I'm gonna put the size box right on top of that, and we'll rename this to icon box. And is variable, we'll make sure it's in the center and do a width and height override of 32 by 32. And we need an icon to put in there. So I'm gonna do a user interface of a widget blueprint that we're just gonna use user widget, and this will be W item row icon, which we can just make a size box and an image. And the size box will be 32 by 32, which we can desire it on screen and see that it's just a square now. And the image will be icon that we can leave as is variable. Then I come into the graph well, I don't need any of these really. I can just make a function called set icon, and this set icon right here will take an input of a texture 2D soft object reference that we will call soft icon. And then you can take this icon, and then we can set brush from soft texture, which will come in here from soft texture, right? So we're not doing hard object pointers, right? Soft texture. So we have this item row icon that we're gonna set there. So we have this, and then what I'm going to do in the item row itself is we're going to make a member variable of that texture as well. So we're going to say soft icon and repeat the same thing. This is a texture 2D soft object reference, right? And this will be instance editable and exposed on spawn. So we can save that. And then on construct, on the event construct, we can make this function called set icon. But what we want to do here in set icon is I want to create a widget, and we're going to create a widget of the item row icon right here, and I'm going to promote this to a variable right here, and this is icon widget, and I want to take the icon widget, and we are going to set icon on that, which is going to ask us for this right here. We could take this, and I can set it right here, and then I can take the icon box right here, and I can add child to this, and I can add the icon widget to it. But why do I want to do it this way? And we'll find out in just a minute here. So I can set icon on here, and on construct I'll set icon. Oops, wrong set icon. We'll grab this set icon from here. So after we set the icon, the whole point of doing this is what I want to do is be able to have this icon filled in here. And whenever you click on this widget and then drag off of this item row, it'll make a little copy of the icon and follow the mouse. And then when you let go in the world, it will spawn the item and everybody will be able to see the item. So in order to do that, we already have the on mouse button down override where we call the item row clicked, and then we just return handled. But if instead of doing that, we can drag off here, I can say detect drag if pressed, and I can click here and say left mouse button again and click this mouse button event and do pointer event. I can click this to the return value here, and then what I should do is, I should do this very good, is this false case, I should return, and if I do return node, I should return unhandled right here because we're not doing anything. So if the mouse button down is not the left mouse button, then I should return unhandled. So we should be doing that to make sure. So now that I detect a drag if pressed, then what I'm gonna do, oops, excuse me, I'm not gonna make a new function. We're gonna come into the override functions, and this huge list right here. We have on drag detected, right? On drag detected. And this return node right here is a drag drop operation object reference. So if we come back into our inventory, which is right here, if we come into the blueprint class, we could say drag drop, and then it'll give us a drag drop operation. And we can say DD item row dropped, right? So DD item row dropped. And then we can drag off this and say create drag and drop operation, which is a static getter or static function like this. So we have this. Now the drag and drop is just going to be the item row dropped right here, and we have a couple things: payload, default drag visual, and pivot, and then there's offset. Now this pivot is like where on the mouse this default drag visual is, and then what are we going to do for the default drag visual is the icon widget, right? So we'll leave the default drag visual as that, and then the pivot, I'm going to do bottom right, so the icon, the bottom right of the icon is going to be in the top left of my pointer. So I'm going to leave it like that with no offset. We'll do that. And then the payload is just an object reference, so you can send anything you want through the payload. So why don't we just send ourself? So anytime in editor, you can always type self, right? And it gets a reference to self. But a thing is, in C++, you type this, right? So if any time you have a valid reference to self that you can use, you can always type in this, and it will give you a reference to self. So we're going to type in this and give that to ourselves. And we will just simply return that. So now on the dragged item drop, this will on detected, it'll create this operation for us. And what that matters is in the, if we want to come next to the function overrides, what we could say is on drag canceled. Here it is, excuse me. On drag canceled means you didn't drop it on top of anything. You're just canceling it, so it's not dropping on anything. This operation, however, is this operation is that drag and drop operation that has the payload and the icon and everything, right? So if we take this operation, what we could say is get payload, and then now that has that payload, the payload is one of these W item rows. So we can cast to the item row right here, and we can cast to that, and from here we can get the entry that it has on it, and we can make ourselves another event dispatcher. And we can say item dropped event, and this will take a new parameter of an RPG inventory entry, excuse me, that we'll call entry, and then we'll just call this right here and pass out that entry. So where we want to use this is back in the inventory itself. We're going to come back into the graph, and first off, when we handle an item received, we're going to come and make the row widget. Now we have the item row widget that we need to fill in the soft icon here. So we have the components. We'll get the inventory component. We'll drag off. We'll say get inventory or get item definition by tag that we have the entry right here. So we'll just grab the item tag, click that right here so we can break this. And we have the soft icon, right? The icon soft pointer that we could put there. And we'll just hide that. So we can satisfy this now, right? So the icon will be loaded. But then now we want to handle the item received, but we want to drag off to this. We have a bind event to item dropped event. We have this here. Add a custom event, and this is on item dropped right here, on item dropped. And guess what we're going to do? We're going to make one that says handle item dropped, right? And guess what? This should all look very familiar. RPG inventory entry. We're doing this to follow the same. Everything looks the same. Everything can be understood, right? Handle item dropped. Everything looks clean. We're going to do this. So the first thing we're going to say is we have the inventory component right here. We can say drop item, and then this is the inventory entry, and we can break this. And for now, we're just going to drop the whole inventory entry right now, however many's in there. We'll get to modifying custom number of items here later, but for now we're just going to drop the whole thing. And then we're going to say handle item removed. Handle item removed, and we can get the item ID out of here because we're going to do that. Now I will say item removed, by the way, we have the unbind all events from action button clicked, but we actually have two more delegates that we're bound to right now, right? So we need to say unbind from the item row clicked, right? We have that one there as well. And then we need unbind from the now item dropped event. So I did not have that unbinding from the other ones before, but now we have this. So we should be able to do this. And then, okay, next we're going to come into the data, into the inventory and the data tables, and then we're going to come to the right hand. And then, so in the bronze sword, we're going to make, what was this one? I think the bronze sword was the cube. So we'll find the 100 by 100 by 100 cube. So we'll have the cube. And then we will do this red devil for the icon. And then this one, I believe, was the cylinder. And we'll do the, oh, that's a big cylinder. We'll do this cylinder, and then we'll do this one here. And then we actually had the consumables. We have using some of these icons already. We could do this access guide here for this one. And then we could do, what could we do here? We could do stat and camera. We'll do a camera spawn for that one. And then if we do this, Okay, and then if we do this right, the next thing we need to do is handle the mouse controls. I want to do a little bit different mouse controls because right now, the way that this works is you can see your mouse, but when you click on it, it disappears, and now the mouse is just, the camera's just moving with you, and that's kind of it. So we're going to change this to more of an RPG style where you can click on the screen and do a little bit different things. So we're going to come into the game, or into the player controller. We have player controller here, and let's see, I have tab, I have debug stuff, but I don't have begin play. So we're actually going to implement begin play here in Blueprints, because then what I want to do is I want to set input mode game and UI. I want to do this here, and I want to say where it says hide cursor during capture, we can do yes right here in the player controller. Look, we can do this again right here, right? In widget to focus none, and we do this, but I want to say set mouse capture, set viewport mouse capture mode, that we are just going to say capture during right mouse down, and we're going to do that. Now, if we do this, then what? Oh, and then, oh, excuse me, then we need to set show mouse cursor to true. Sorry, we do this. So if we do this, then what this means is now our mouse is not going to disappear, right? So we have our mouse, and we can click on the screen while we're doing this, while we're moving around. And then while we hold the right mouse button down, now we can move our camera around and reposition and move 360 degrees. And the player is moving like this right now. We can change that as well. We can manipulate that, but at least we get the option right now to have our mouse right here on the screen, and we can click and move and do this. And the whole reason we want to do this is because now if I come right here, I have all of these. I want to be able to click, and now I'm dragging this little red devil out here, and then if I drop him, now I have a cube, and this is on the server and both clients. Right, so now everybody sees that. And then I can take this broken mace, and I can drag this broken mace right here, and now I have a cylinder that spawned in there, and the mana potion. And I've got a camera for everybody. So that's drag and drop operations.